Welcome to clickmyproject.com. Now we discuss about the product improved tampering detection localization in digital image forensic based on maximal entropy random walk. Now we discuss the abstract for the process. In this paper we propose to use an maximally entropy random walk on the graph for tampering localization in digital image forensics. Our approach serves as an additional post-processing step after conventional sliding window analysis with the forensic detector. Strong localization property of this random walk will highlight important regions and then the background will be eliminated, even an noisy response map. Our evaluation shows that the proposed method can significantly outperform both the commonly used threshold-based decisions and the recent proposed optimization-based approach with the Markoving prior. The input images were identically over and segment with the SLIC algorithm. The features were extracted from the blocks based on the scale invariant feature extraction algorithm that is known as the shift algorithm for the forensic detection on the matching, and the label features were point matching. Now we discuss the flow diagram for the process. This is the overall flow diagram for the process for tampering detection. At first, the input image is taken from the dataset. The dataset is the folder which consists of the several images which is undergone for the process. After getting the input image from the dataset, the over segmentation is carried out. In the over segmentation block, the segmentation is carried out. After the over segmentation, the block separation is carried out. In the block separation, the image is converted into one particular small blocks. After the block separation from the image, the block feature matching is calculated. The block feature matching is calculated by extracting the features from the particular blocks. After extracting the features only, the block feature matching will be carried out. Then the local feature identification. In the local feature identification, the feature points are identified by the coordinates of the image. Then the local feature matching is carried out to match the particular region according to the feature region. Then the forged region identification. After the local feature matching, the corresponding area of forged is identified or marked with a red color indication that is known as the forged region identification. In the forged region identification, if the user is tampered, the image means that area only identified by the red indication. Then the performance measure is carried out. In the performance measure, the efficiency of the process is analyzed. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the directory as in the code. Now click the main.em file in the current folder and right click in that file. Now execute the file using run. Now the dataset folder was opened. In that you can see the several dataset images. The first image is the original image, and the other than the first images are the tampered images. Now I can give the input as an tampered image and click the button open. Now the input image is shown in the figure 1. This is the input image which I have given as an input. Now the SLIC segmentation is carried out for the input image. After the SLIC segmentation, the superpixel regions are marked and then notified in the red color region. This image is shown in the figure 2 with the title SLIC image. Now the features of the shift is calculated. Shift is a feature used to detect the key points of the each and every edges in the images. It is useful to detect the tamper region by the structure and the shape of the object. Shift features will take several minutes to calculate the each and every edges because the shift feature is running as per the number of pixels present in the images. After the SLIC, the shift feature are also calculated. This is the shift feature of the each and every points for the superpixel regions. Now the labeled features are pointed out in the figure at the title of labeled feature points. After getting the labeled feature points, the merged region points are extracted. Here we can see the clear exact regions of the labeled and the merged regions. Now the exact tamper region will be indicated like this. The tamper region is in the left position. Now the red color indications marks the tampered region.